Hi everyone, my name is Huseyin. I am software development team lead of Hazelcast Cloud. In this session, I will try to provide some best practices about Golang in theory, and I will do a demo about what we see inside the theoretical information. So as an outline, we will see what is Golang. We will see how to set up development environment, a couple of Golang examples, and by using these examples, how to write tests, and at the end, we will see how to build an artifact out of these Golang projects to be used inside CI and CD platforms. Golang is a statically typed compiled language, and it is originally designed by Robert Gressimer and Rob Pike and Ken Thompson while they are working at Google. This is very similar to C language, but there is a memory safety and the garbage collection stuff in this language. Remember, C and C++ times you need to alloc and malloc memory in order to do some operations, but here you are free to do anything without touching on the memory part. And if you want to deep dive any kind of topic in Golang, you can just refer the landing page. Of course, it is golang.org. Before writing code, you need to download the Golang binary in your system. You can just go to Golang download page and download your distribution based on your operating system. In my case, I'm using macOS, and I will download this macOS distribution. If you are preparing a project, creating a project, these project dependencies are a very important topic. In Golang, there is a system which is called Go modules. With Go modules, you can implement modular applications, plus you can manage your dependencies. In the examples you see, I say go mod init and my version control system URL. It will create a modular application. Of course, it is empty. There will be only one file, which is called go mod file. And here, after go mod init, you see it is dependent to github.com, my author name, and my repository. But you can use GitLab, Bitbucket, or maybe if you have a custom version control system service, you can also use that. Inside the Go module, when you have a look at module file, you will see a module information, Golang version, and if you have dependency, you can see also dependent sections by using require keyword. In order to see all the dependencies, you can say go list-m all. You will see your exact dependency plus the recursive dependencies needed by this library. Okay, you know how to use Golang, I mean the distribution, and you know how to generate an empty project. Now, you can select one of your favorite IDEs, but as an example, if you are using Vim Terminal, you can use Vim Go plugin. If you are using IntelliJ products, you can use Golang, or you can use VS Code as an alternative. If you are using Vim Terminal, then by using go run command, you can just run your application. If you are using Golang, you can define a run configuration to run your project. In VS Code, you can run your application by using Control plus F5. So this is very fresh start about writing something and just running your application to see what's going on. When you create a resource file in Golang, it will start by a package statement. Here I am saying that my package name is main, and right after that I have some import statements. I depend on context package, FMT package, and GitHub package here. If you define your package name as main, this will be an executable rather than a library. For example, when you have a math package, it will be a library package. Then you can put your functions inside it. But in our case, this is just for executable. Very initial principle of any kind of programming language, variable declaration. Here, in the first example, you see I declare a variable. I am saying that count is a variable and its type is integer. The second line, you see I am assigning some value to it. Count is equal to 5. When you say limit colon is equal to 15, you are just declaring and assign a value to a variable. So this is also known by Golang language. And this following example, you see I am defining a slice, which is called list, arrays, array list on other languages. It starts with square brackets, and I am saying that this will be a slice of integer, and I put some values inside it. In the following example, you see there's a nums slice, but this time I am allocating a slice size. So I'm saying that there will be an integer slice, but its size will be 3. And the very first value, the zeroth index value, will be 1 in my case. Also, you can define two-dimensional slices here, and the value is float 64. As the final example, you see I'm defining a map. It is a key value store. In my case, keys is data type is integer. The value will be string. Let's say that this is the student information map. The key is student ID and the value is student name. In order to declare a function in Golang, you can use func keyword and it followed by a name. Here sum, we open the parenthesis and put arguments inside it, a and b. The return type is integer, and of course you provide your return function body. In the second example, very same, but the return type is a bit different. For example, if you have Scala before, you remember the tuples. So sometimes you may need to return multiple values. In my case, I just wanted to state x and y coordinated separately here. In the third example, you see there is a do something. In do something, the function name starts with a lowercase letter. That means this function will be a private. The first two will be exposed to outside, but the third one will not be exposed to outside. When it comes to usage, you see I am saying functions.sum. Provide your arguments and it will return a value, just assign a variable. Again, another example, get coordinates. You see it returns two values and I am using x and y in order to use different references to these returned values. Control structures are very important to define your business logic, right? You decide on something. I define an if function here. It takes a parameter category. If category is shoes, I print shoe. Otherwise, I print not a shoe. The main difference between other languages is there is no parenthesis right beside the if statement. In the switch statement, very similar case, you provide your variable and a switch statement followed by one or more cases. And at the end, there is a default use case. If it is a PC, if device is a PC, just stay at home. If it is a laptop, you can go outside. What about for loops? In Golang, again, there is no parenthesis. I starts with 0 up to 10. We increment I by 1. Here, if the number is divided by 2, I'm saying continue. That means just skip to next iteration without printing the current number. And in the second example, I define a counter variable with initially initialized by 0. And there is no statement beside the for. That means this is an infinite loop, right? And inside this infinite loop, I am saying that if the counter is equal to 10, just break. That means just break the loop. Otherwise, it will increment counter by 1 here. There is no for each function in Golang, but you can simulate it. I defined the number slice that contains 4 numbers. Inside the for statement, there is a key value pairs. But why there is an underscore in the key part? Because I am not interested in the key part. So in Golang, if you define something but not use it, the compiler will start to complain about it. So if you are not interested in it, just put an underscore. You say range numbers, and in this time you will get number in iteration. We are just printing the specific number inside the slice. In the second example, I have a map. This time it is string, key is string, value is string. It is simple country code and the country name key store here. This time I am interested in both key and the value part, code country, and I am printing the code and country at the same time into the standard output. So I have functions, variables, etc. Let's try to test this one. In Golang, you can use built-in packages like testing, but also you can use Testify, which is a third-party library, if you like more assert-like operations. If you need mock-related operations, you can use Mockery, which is a third-party library. Also, you can use Golang mock in your system. So I will not deep dive into mock part because it really deserves a separate session. But when it comes to unit test part, let's try to test a function which is called Fibonacci. I have a Fibonacci function. It accepts a number as a parameter and it tells you what is the value at that number index. So here I am injecting the testing T, the reference to my function, and keep in mind that my function name starts with test because this is the naming convention. If the result is not 610, it will start to complain about I want 610 but got another result. But what about if you want to test this function Fibonacci with different kind of multiple inputs? Then you can use test table here. Inside my test Fibonacci in batch function, I am defining a struct, slice of struct, and it accepts 2 parameters, input and expected. Here I have 5 scenarios, test cases, and inside the for loop, I am iterating these parameters, calling Fibonacci function. I am trying to verify if actual is equal to parameter or not. Otherwise, it will start to complain about this one. You write test, but what about coverage? You need to know how much part of your code base, production code, is covered by tests, right? Here, when you say go test, provide the test folder, and when you say dash cover, it will calculate the coverage. When you provide dash cover profile and some file, it will put the report in this file. So this is very useful, especially if you want to do further operations, something like generate HTML output, like operations. Okay, we generate these coverage because they are all being used inside the CI systems, right? For example, if you are using Sonar, then this coverage file will be used for Sonar to analyze your code base, maybe put as some kind of thresholds. In CI/CD part, I will not talk about something like Jenkins, maybe, or GitHub Actions or something like that. I will try to give information about the very minimum unit of the CI/CD systems, the artifacts. Golang has built-in tools to generate artifacts based on our distribution. So in order to see supported these platforms in Golang, you can use go tool dist list. So in the table, you will see your supported operating system and the architecture. In my case, I'm using macOS. The value is Darwin AMD64. In order to build a project to generate some binary, you can provide your operating system and architecture. And when you say go build, the binary will be generated based on these distribution parameters. So why do you need this binary? Because it is very popular inside the containerization world. For example, I create a Docker file and I put some contents inside it. So here I am saying that I will drive my Docker image from Golang and I provide an alias as builder. I create a folder. I make my folder to src app. I copy all of project files to the Docker context. I download my dependencies by go-mod download and generate my binary. But this time I'm providing -o parameter to change the output name. This is the first stage. But in the second stage, I am deriving my Docker image from scratch, which is the zero-sized Docker image. I am copying the binary generated on the first phase to my stage. Then I am providing this hello binary as an entry point into this image. So we are calling this strategy as multi-stage Docker build. I believe that the theoretical information was enough for this session. Let's have a look at a couple of demo by using these theoretical informations. Let me open my terminal first. I will create a folder. Let's say that conf demo. Here, go mod. Okay, you see there is only one file here, go mod. Let's open this one by using Golang. I am using Golang for my projects. File, open. Presentations, and this one. Let me open, okay, it is already in presentation mode. So here, when you open go-mod file, you will see there is only module information, plus there is a version information. I will start creating a main file, main. In this file, this is Golang by default adds this package, the folder name as a package in this file, but I will change this one as main because I want this package to be executable. Func main. You see this main is a special function. You can run it. Let's do our famous stuff. Print when hello world. Okay, when you run it, you will see it is in the output. Cool. Let's start with the variable declarations, but I will create a separate directory for this, variables, and a separate profile variables. In this file, let's define a function. Let's say that run. In this run function, we can define our variables. Var count, let's say that this will be an integer, and the value will be 34. Just print this one. You see, it complains about you defined it, but you have not used it. Count. Okay, so let's try to run this one from main functions. Variables, run. You see this import is automatically added to this resource file. Hello world 34. Let's continue to define a couple of variables here. The inline one, limit is equal to 10. What else? We can define the slice. Numbers is equal to square bracket 2, 5, 7. What else? We can define a limited slice here. Make. You can define this length in advance. Let's say that this is 2. This is limit. This is numbers. And here, let me do something. The first value will be this one. Duplicate it. Let's try to compile this or run this. Let's see what happens. Okay. Okay, I did something wrong. 1, 2. You see, index out of range 2, because you define the limit 2, but you're trying to add the third item, right? I will delete this one to make it work. So if you do not add, for example, second value, then you will see the value will be filled by the default values, which is 0 is the default value of the integer type. What else? We can define a student snap. In this case, I am saying that the student ID and the grade, float 64. Here, student ID is 1, the value is this one, and student ID is 2, and value is 100% here. And just print students. This is wrong. All right, let's write this function, run this function again, and as you can see, it is correctly working. What about functions? Let's switch to functions. Here I define another directory, functions. Just create another resource file, functions. Here I define sum function. It takes a and b as integer and returns integer. You see, you don't need to define integer for all of the types. If they are repetitive, you define your variable names and integer. I think this is valid for TypeScript also. You return a plus b, right? Let's do another one, func. This time it will be multiply, a, b, they are integer, returns integer, return a, b. So here, in this case, one function starts with capital letter, another starts with lowercase letter. Here, let's go to main function. Just comment this one. Functions.sum. But what about, you see, there is no multiply. Why? Because it is private. That is the convention inside Golang. Okay, inside sum function, just provide 45, 55, and wrap it with here. Hello world, the value is 100. This is it for functions. What about testing? In my functions package, I'm creating a file which is called functions test. Okay, you see the icon is changed for test in Golang. In order to write a test, you can start with test keyword, and it will automatically suggest you to sum. So I am testing sum. Result is equal to sum 2, 3 here. If result is not equal to 5, then t.rf wanted 5 got result. Let's run this one. So basically, we are using t reference in order to verify something. But let's say that you change this function to something like this. Then when you go back to function and run it, you will see wanted 5 but got 6. So when you change production code, by doing this, you may understand, okay, there is a problem. Let's delete this one. Okay, what about test tables? Func, this time, let's say that test sum in batch. T testing T. Here, I will define a struct. Something like you define a JSON inside JavaScript or TypeScript, or you define a map in any kind of language. So inside the struct, you can define your variables and types, something like this. This is slice of struct. So let's say that you haven't defined any kind of object. You don't have an object, but you can define something like this. This will be the input, let's say that integer, and the expected output. So this is a table. Now I can put my values inside it. When you, okay, this will be A, there will be a B, and expected. So if you provide 2 and 3 to the function, you need to get 5. What else? If you provide this one and this one, it will be, let's put some wrong values. For example, 100, 200, it will be 400. Okay, this one. Then, in order to run it, I'm not interested in the index, I'm only interested in parameter, range, parameters. Let's call the sum function and provide parameter.a, parameter.b, then parameter.b, assign this one to a value. Okay, sum is cool. If sum is not equal to parameter.expected, then you can say t.rf wanted something got something. So in wanted part, parameter.expected, another one is sum. So let's execute this function and see what is going on. You see wanted 400 but got 300. You see, that means this shouldn't be 400. This should be 300. Another one wanted 5 but got 7. You see, this is 7. Just execute this one. But normally you cannot, you don't change test code most of the time. So you change test, but right after change production code. Okay, this is test. What about coverage? You can just select this one and run with coverage. You can say that. Or you can do this, just open terminal. in terminal, go test -cover and this one. So you see the coverage of the functions is 50%. There's no coverage in variables part. In functions, because there is also multiply function, but I cannot test it right now. And what about this coverage out file? Let's test. Yeah, you see, go to cover. I just wanted to see HTML output of this one. When you do that, you will see the HTML output. I cannot show it right now, but let's continue with the Golang part. What can we do next? Yes, so we can talk about building artifacts, right? Here, let's try to build an artifact. Go build. In my case, this will be let's say the Conf42. When you do a build operation, you will see a binary will be generated, something like this. And when you execute it, you will see the same output. Very simple. What about using this one in the containerization, generating a Docker image? Let's create a Docker image for this Docker file. Here in Docker file, I will start from Golang as builder. Okay, this is my first stage, and I will do run. I will create a folder first and change my work directory to this one. Okay. Then I will copy everything from my project folder to Docker context. I will download all the dependencies if I have any. Then I will generate my binary. Go build -o. So this will generate a binary. Then in the second stage, I will use scratch image, okay? Then I will copy from builder. So from the first stage in this path, I will copy from the builder at this page to my path. Let's say that bin app, and just put this one to entry point as bin app. Let's try to build this one. Docker build -t Conf42, this one. Let's wait for this. It will download the Golang Docker image and use it, build the Docker image, and then generate something. Let's see Docker images. You see we have Conf42, and the size is only 1 megabyte and 94. You see, when I run Conf42, I got exactly the same output from this part. So that was all for this session. Thanks for listening to theoretical information and watching for my showcase about the Golang usage. Hope it was a very useful session for you. Maybe see you in the next sessions.